Recorded rolling. It's Wednesday, October 22nd. We're on lesson 4.3, operations with polynomials. You guys know Alex 414243 is due Friday. Tomorrow will be an Alex day. So today you can either read the book or watch the pre-recorded video that they posted, or you can work on Alex, and then tomorrow can help you guys out too. Guys, your module 3 quizzes. I got return to your folders. Here, let's do something a little different here. Guys, here's what we're going to do on Friday. So on Friday, we're going to do a quiz retake. Recently, some of you guys did pretty good on this quiz, and then a lot of students didn't, so it's kind of a mixed bag. So I want to try something a little different. We're going to do a retake quiz on Friday, and I'll put the better of the two scores in the grade book. Now, I'm going to, if you score better on the retake, then I'm just going to subtract 1 point, just so that if it ends in like a 4 or 9, then I'll know that in the grade book. I'll let you check it. Right? So yeah, the higher grade's going to go in the grade book. And there were a handful of hundreds. I think there were like 5 or 6 or 7 students who got hundreds. So if you also ace this one on Friday, so if you ace both of them, then I'll put 105 in the book. All right, so we'll do it that way. Oh, and guys, it's going to be the same quiz, but you guys know there's different versions, right? There's different versions.
Oh, it's the same quiz we get a retake?
Yeah, guys.
Oh, yeah.
I mean, the same quiz, just with the same questions, exact same questions. Just the numbers will be different. That's all. Okay. It's different versions. Okay. So as long as you know how to solve those, and you know what, if you have any questions about how to solve any of those, then you got a couple of days to after you do. Right there. All right. So let's see. What's this 4.3 about? Here, I'll give you guys an overview. It is here. And so this operation for polynomials, which basically addition, subtraction, and multiplication. So I'll do a couple examples with you guys on this. And then, as always, there's some fun word puzzles. So there's an example here with like a 3-layer cake. Example here with a box. There's this is fun example where they take polynomials. Like, guys, x squared. Could you think about it as like a square that's x times x? And then if you just had a plain x, could it be 1 times x? And if you had a constant like 1, that could be 1 times 1. Right? So you can think of this sort of like areas of shapes. I like that example too. And so all those they just pointed out, I go over in more detail in the main video, but here with you guys right here, I'll do a couple basic examples. So let's do one addition type and then one multiplication type. Right here, its addition and subtraction are really similar. So here, actually, I'll do subtraction here. This will do. So what if you have 2x to the 5 plus 11x to the 4 plus 7x minus 8, and that's all grouped together. Maybe it's like y equals that polynomial. Maybe you have y equals a different polynomial. Maybe you want to subtract this one. So you're subtracting this other polynomial. 5x to the 4 plus 9x to the 3 minus 3x, and then plus 4. Okay, is it? So one polynomial minus another polynomial. Hey guys, are you allowed to combine like terms? Like x to the 4 and x to the 4? You can add put those together. Okay. Now, one thing I would do, you see how you're subtracting off this whole thing? Now, just me, I would go ahead and distribute this negative. So could you guys, how did you do that? Could you do this? Could you switch all the signs? Like plus, minus, minus, plus, minus. I put that in pinky because you can definitely see what I did. You see, I just swapped all the signs because I distributed the negative sign. Okay? And then from that point of view, here, I'm going to rewrite this. 2x to the 5 plus 11x to the 4 plus 7x minus 8. Okay. And beneath that, I'm going to write this other polynomial. And I'm going to try to sort of align the terms. So I got a negative 5x to the 4. And I'll put that under x to the 4 so I can add vertically. Negative 9x to the 3. Well, I don't have an x to the 3 term, so 9x to the 3. Plus 3x. And I do have the 7x right here. And then plus 4. Okay. So I can now add these two polynomials. Swap that. And so I got 2x to the 5. Guys, how many x to the 4 do I have? What's 11 minus 5? 6. Yeah. So plus 6x to the 4. Okay. Now I only have this x to the 3 term, so I got minus 9x to the 3. Okay. I have a couple of x terms. How many x terms do I have altogether? 10. 7 to 3. So that's 10 x's. And then negative 8 plus 4 is negative 4. Okay. So that's the answer. That's all. That's not too bad, right? Is that okay? Yeah. Right. So that's just most. It started out subtraction. I flip the sign, make it addition. Addition, subtraction. Okay. Now, what about multiplication? So look at a multiplication. Let's do this one. Multiply polynomials. So example 5. We got a 3. No, they're saying 3. A. Yeah, I'll leave it as A. A could be kind of like X, right? Maybe it's good to see different kinds of variables. Plus 5. And then you got an A minus 7. And you got a 4A plus 1. Okay. Right, so are you guys thinking about FOIL, FOIL? Right. So what I can do is I can multiply these first two polynomials together, right? And then I'll worry about that third one later. Right, so I'll go first, outside, inside, last. I'll spell it out. FOIL, FOIL. Okay. So what's that? That's 3A squared. Plus 5. Well, yeah, here, let's do minus 21A. Plus 5A. A. And then minus 35. And this is all times, I haven't touched this 4A plus 1 yet. And before I do, we do one more thing. I'm going to clean up this a little bit. Let's have these A terms together. So go 3A squared minus 16A minus 35. And I have a 4A plus 1. Okay. Now, because now I have a trinomial and a binomial. So I might call this like a superfoil. Sometimes I say that. I don't know if that's an official term. But you have to multiply every term by every other term. So here, if you think of it from the perspective of this 4A plus 1, this 4A and also this plus 1 each have to be multiplied by these other 3 terms. So I need 4A times 3A squared. I need 4A times negative 16A and 4A times negative 35. And then I also need 1 times each of those. Boink, boink, boink. You guys see it's going to be 1, 2, 3, 4, 5, 6 different operations. And then I'll add everything up. Maybe I'll have like terms that I can combine like terms out into the fact. So let's start with this here. Guys, what's 3 times 4?
12.
12? And what's A squared times A?
25.
A to the 3. Okay. So we got 12A to the 3. That's my first term. Bing. That's just that right in. Okay. All right, next. Let's go straight over right over here. Minus 16 times 4. Is that 64? And I'm subtracting. 64, and that'd be A squared, because A times A. Okay. Next one. 35 times 4. Well, 35 times 2 is 70. Times 2 is 140. So I think this is negative 140. And I also have that A. All right, next. Okay, so I've exhausted the 4A. I just multiply that by all 3 of these. Now, the 1. 1 times 3A squared, well, that's just 3A squared. And the 1 times negative 16A is negative 16A. And the 1 times negative 35 is negative 35. Okay, so that could be the answer there. But I can consolidate this a little bit. What did I see? Here's an A squared term, and here's another A squared term. Here's an A term, and here's another A term. So I can combine like terms, right? Combine like terms. So the final answer, like the simplified answer in standard form, would be 12 A to the 3. Okay, now minus 64 plus 3, that's like minus 51. That's A squared. Okay, and then this is what, negative 156 A. And then minus 35. That should be the answer. So regardless of what A is. Like that. Right, you guys good? Right. So the examples I did with you guys, these are like just abstract math. They got X's and Y's and A's, like real abstract. Okay. Let's look a little at some of these word questions. Just think like, how would you set this up? We got Byron baking a 3-tier cake for a birthday. Each tier will have half the volume of the previous tier. And the bottom tier, he names the dimensions in terms of X. So 4x minus 3, 2x plus 1, and X. Okay. So maybe they're like different customers that want different size cakes for different reasons, but maybe they all want the same proportion cake. They all want, maybe there's like some scale model. Like, oh, we want it to look like this famous Aztec pyramid, and well, you have to look like this shape. Okay. We want to scale it up or down by some value X. Okay. So, guys, could you do length times width times height to get the volume of the first tier? And if you want to add the tiers above it, could you say plus half of that expression to get tier 2, and plus half of that half to get tier 3, and then add that all together? So think how that could work. Right? See. Okay. Yeah, and again, there's there's another cube down here where they name the sides in terms of A, B, and C. We've got a sailboat here. We've got these shapes here. Okay. Yeah, so I go over those more detail in the full video. Oh, I forgot to point this one out. Okay. This is the last one I saw in the video. It involves the street. So there's this town center, a memorial in a town center. So they want this memorial space in this white circle, and then they want this walkway that they shaded in blue going all the way around. Right. So they've got some radius R mark, but they didn't tell you what the radius is. They did say they want the walkway to be 12 feet wide, and also they want the area of that walkway, that blue shaded region, to be this many square feet. They gave you a hard number. Right? So there is enough information here at that point where you can solve for R. And you do it with polynomial operations. All right. So yeah, I think it's a pretty good overview. I will walk around, help you guys out. Any questions you guys have, let me know. Whether it's on this lesson or if it's about Alex or if it's about how to solve any quiz question, I will help you out.